Hi, it's Cyprien again, and welcome to the third part. So in the second part, I show you how to write this simple geometry, and this is basically creating a grid like that, and I'll show you that you can control the size and the length, the number of nodes, everything you want in this grid. Now in this part of the tutorial, I'll show you how you can change all those numbers into parameters, because when we build a very complex model, we don't want to write all the dimensions like this. Otherwise, we'll lose a lot of time. So let me show you how to change all of this and to make it into a code which is easier to read. So I'll accelerate the process because it's not very interesting. Let's review now the simple changes that I did. So this is exactly the same thing than before, except that I replaced all the numbers here by variables. And here I'm just defining those variables. So in OnScale, you have to use the keyword symb in order to define a variable. This is because this script language that OnScale uses is called a symbol language. So when you define a variable, you call it symb, the name of the variable, equal, and the value. Make sure you leave a space in between each of those things. So in between the x and the equal and the value here, all must have a space. Also, some variables will require a real value and some variable require integer value. So by definition, I and j are nodes, so they require to be defined as integer, while x and y are coordinates, so this is real values. So what I did is that I basically said, okay, I want a grid with coordinates 0, 0, 5, and 1. So I'll just call those coordinates x1, x2, x3, and then the nodes which are associated to those, I'll call those nodes I1, I2, and I3. And then I do the same for y and j nodes. So you see that I always have a pair of coordinates and nodes. I have two kinds of coordinate system, the XYZ coordinate system and the IGK coordinate system. So here I have no Z and K because I'm in 2 dimensions, but in 3D you'll have K and Z as well. Now let's have a look what I actually did in a graphical manner. So here you have the domain that I generated using this script. So what I did is that I basically defined 4 different spaces in this domain. And I basically said, okay, so I will give a name to those points of the grid. This point here will be on the x-axis will be x1, this will be x2, this will be x3. And I know the exact value of the coordinates of those points. And y1, y2, y3, exactly the same. And now I know the associated nodes to those coordinates. So to x1, I will associate I1, to x2, I will associate I2, and to x3, I will associate I3. And basically, this is how you build the grid. So if I come back to my code, it's still pretty long. So it's still not very useful and very user-friendly to write it like that. So this is not the best way to write it, obviously. So there is an even better way, which uses some macro functions, which will directly write out the value of the grids. The simplification I'll do now is the following. So instead of declaring the absolute position of those points and giving the associated nodes, I will declare what is the distance in between those points, the coordinate distance. So we'll call this distance here x1. I'll call this distance here x2, and I will do the same for y1, y2. Here's how I will change the script. So I will define the position between points that I will call x1, x2, y1, y2. Actually, I should have chosen a different name, would have been less confusing with the absolute position. Then I will feed that to a macro, which will provide me with the absolute value of those positions, and it will also call those values x1, x2, x3, y1, y2, y3. The name are the same, so I should actually change that to something else. But anyway, you understand the principle. Then I will feed that into another macro, which will generate nodes which correspond to those absolute positions. So at the coordinate x1, what is the y1, what is the I1 node corresponding, etc. And in order to work, I need to provide one parameter, which is the mesh size. And the mesh size will be contained into a box. Of course, this time I'm generating a grid which is equally spaced everywhere. And once I have all of that, I will feed that and change my geom and grid command so that everything becomes parametric. So then the only thing I'll have to do is set up the position between different points of my model, set up the mesh size, and everything else will be calculated. Let's modify the script. So the first thing I'll do is that I will take this grid and I will put it below the definition of the variables, and you will understand why a bit later. And instead of defining x1, x2, x3 like this, and y1, y2, y3, I want to make this part parametric. And I don't want to specify exactly the number of nodes that should be associated to each x. So I'll show you the way to do this automatically. So here, I will use a new command, which is macro command. So it starts also by symb, and then the command is Keycord. And if you look at this command in the documentation, this will tell you that this option allows a quick method of creating XYZ key points based on the distance between points, and this is important. So I'll have to do a few changes because now I have the absolute position of this point, but the Keycord command requires the distance between points. So instead of, let's say, x1, x2, x3, I just remove x3 and I need to distance 0, 5 and 0, 5. And like that, I will have Keycord. And Keycord must be, so the first argument is the direction, which is x. The second is the index x begin, so it's 1. I will begin at 1. After that is what will be the first value, 0. And then what will be the distances between the different points. So that's where I write x1 and x2. So this is a macro command that will generate from the distance between points, it will generate my my absolute coordinate points. And now I need to add a new command which will tell me actually what is the, because now I have like two distances, but I may have many points generated out of this. So I have 3 or 4 points maybe. In this case it will be 3 because I had 3 before. So I need to know what is the size of the array where those x will be stored. So I use command symb get. I use the braces. I give it a name idx, and I use the function rootmax x. So what this function is basically doing is that it's extracting the maximum maximum index of the X array coordinate, and then it is putting that into IDX variable. So the IDX will tell me how many X coordinates, absolute coordinates I have. And now let's replace this I2, I1, I2, I3. And instead of basically telling which number of elements I have, I want to define, I want to mesh with a certain mesh size. So I will define a new variable called box. Symb box equal, and I will give the box a certain size, 0.02 for example. And this size will be my grid size. So I'll delete that, and I will use another macro called symb key key index x. This time the direction is I. It starts at 1, and the final number is IDX. So that's why I need to have this IDX. And the number of elements I want is 1, and the spacing is box. So this function, what this function will do is that it will generate a certain number of mesh and nodes in the I direction, and it will automatically assign that to my coordinates created here. So, and now I will have much more than 20 elements for my grid. So what I need to do is that kind of generate the grid in function of the value that will be created by those macros. So for that, instead of 20, I'll put the value I and IDX. So why do I write it like this? I write it like this because the symbol language works like this. When it will read this line of the script, it will first read the last part, the $IDX. Then it will go and look into this IDX and say, what is the value stored into IDX? Oh, this is 3. So it will replace this by 3. And then the grid will be created with a maximum number corresponding to the last node of the grid. So if your last node is 2000, it will automatically put 2000 here. If your last node is 5000, it will automatically replace here. So it becomes automatic. You don't have to tell the exact number of elements in the grid. The element of the grid is linked to these macros, which are linked to the box size. So now you can change the box size and the grid will automatically change. And now let's do the exact same thing into the Y direction. So I could actually first show you the model. Try to run that. Okay, there's a small problem here. And if I assemble 2, I think I deleted a value without. Okay, no problem. So let's preview. So let's preview now the model. And this is what you get. So in the J direction, it didn't change. It's the same than previously because I didn't set up the parametric stuff. But you see that in the X direction now I have uniform mesh size. So let's change the X, the Y and J in the same way. Okay, the change is done. Now let's preview the model. And now we see that I get an uniform grid. So if I change my box size, let's say 0.2, and I now preview my model, okay, maybe this is to 0.0.1. Okay, 0.0.1. Yeah, because if I put 0.2, the grid is too big and I cannot associate this. Well, I could try. So if you want to comment out a function, you can put like that a comment. And now I can try 0.2. I think this time it will work. Yeah. So previously I associated to something bigger than the grid, so it cannot work. And this time this grid is very big, and I can also preview. Oh, maybe this is too small. Okay. Okay, very small. Right. So it became parametric. So now I can just change the size of the grid and this will change. Now you saw that my region here has been defined with by directly specifying the nodes. So there's a problem by doing like that. When I change the mesh size, sorry, didn't save, I think. Yeah, it's very, it's here. Okay, very, very small. Almost cannot see it. Sure. Let's put 0.0.2. Yeah. So the problem is here for 0.0.2 box size, my position will be here because I'm fixing those nodes. But if I change the mesh to 0.0.1, then you see the box moves. So the region actually is not fixed. So instead of fixing directly the number of nodes here, I will fix the key points provided. And by the way, this geometry here also should be changed. So I forgot that. So instead, now we don't need to specify it like this. We can also simplify that quite a lot. So now I can directly say this should be specified from x1 to idx and y1 to gdx. So yeah, like this. Same then. Yes. So in this way, I don't need to define. I can leave it like that. This will automatically creates the grid based on and associate the geometry to the biggest coordinates of the grid. And here, now I can just specify certain, so it's called a key point. So when I call it like that, I1, I2, and you can actually view those key points in the variables. So the key points generated by this macros can be viewed into this variable tab. So now I have 1, 2, 3 key points, which are defined at, so this is node number 1, node number 51, and node number 101. So I will associate the steel 2 to the area defined by like this, between key point 1 and key point 2, and in I and J direction. And now I'm selecting this whole area. And the advantage to do like this is that if I change my mesh, I make it smaller, this area will stay B6, will still be the same area, but the mesh will change. So I can refine my grid and my geometry will stay the same. So this is the principle of how the geometry works in OnScale. So most of the time, you don't actually have to write this kind of code either, because this is generated by the GUI in the designer mode. So when you're into the designer mode, the GUI will generate this code for you, and you don't even have to bother about doing this type of variable association and all of this. But I'm explaining all of this to you so you understand the principle of how those functions work. So in the next video, I'll go to the next part, which is how we can simulate something.